Hey, 8th graders, welcome to another week of our virtual learning or e-learning. We're going to have a couple of lessons this week. We're going to have one today and tomorrow. And then what we're going to do is we're going to review for our, I believe it's a quiz at the end of the week. What we're going to do today is we're going to actually look at your workbooks. So if you get page 283 in your workbooks, I'm going to work through all the odd problems, and then you're going to apply this to the even problems on this lesson. A lot of you should already have your calculators. You're going to definitely need them tomorrow. Today would be very helpful to you too, so please have those with sine, cosine, tangent for tomorrow's lessons with the trig ratios. Okay, so I'm looking at number, I'm actually going to start with number 3. Find the total cost of a $125.65 pair of boots after an 8.5 sales tax is included or is added. So I have 125.65, 125.65, and then an 8.5% tax. Okay, just because you can use your calculator doesn't mean that you don't have to show work. All you have to do is show me the numbers you get when you put in the calculator function. So that's how we're going to figure it out. All right. One of the main things you're going to do in this lesson is multiply. And again, you could use your calculator to do so. But here you have to know what you're multiplying for or what you're trying to get. So I'm trying to get what's the total cost if an item costs this much money and has that much of a tax. So really what I'm trying to find out is what is 8.5% of 125.65. So what is 8.5% of this 125.65? That's telling me how much tax will I pay for that item. Now, when you're looking at this 8.5% and all these problems, you have to change these to decimals, and your calculator might not do it for you, or it's easier for us to do it. So if I have 8.5%, percent means over 100. So I divide it by 100. So really I have 0.085. So 0.085 times the 125.65. And that gets me $10.68. Now that's how much money I'm going to pay in taxes, but it says find the total cost. So I'm going to take the 125.65, and then add to it the 10.68, and I should get a total of $136.33. That's how much money you're going to pay for that item if you have an 8.5% tax rate. So very practical lesson because we're going to deal with taxes the rest of our lives. And so we need to know how to work those problems out, even with the calculator. Because if you just put 8.5 times 125.65, you would have gotten a very big number and it would not have been correct. Okay, so that was number 3, how to find the total cost. So sometimes you're adding a tax, sometimes you're subtracting a tax, and sometimes you're just trying to find that percent. So that's why this lesson is called applying percents. Number 5, Megan earns a 1.5% commission. 1.5% commission on her total sales. One day her total sales were $6,258.95. So that's how much she sold. And commission is basically you make a part of what you sold. So if I'm a salesperson and I sell, for example, chairs in our room, the more chairs I sell, the more money I make. And I make a percentage of the sales. So basically for her, for every chair she sells, she gets 1.5% of that cost to the person who's buying it. So how much was her commission? How much did she make? So let's look at this. I'm looking for what is 1.5% of 6,258.95. Okay, so I'm going to make sure I remember this is a percent. So if I want to make it just a decimal, I move the decimal point twice. So I'm looking for 0.015 times $6,258.95. Okay, and that gets me $93.88. Remember, round it to the nearest cent because we're dealing with money. But $93.88. So that's how much commission she makes. I don't want to add this to the amount that she sold. This is its own figure for commission. So like if I sold this much on a given day with that percent commission, this is how much money I made on that day. So that's what we're saying on problem number 5. All right, number 7. Number 7, find the amount of simple interest $1,500 would earn in 4 years if deposited in an account that paid 2.8% interest. Okay, now this one's a different problem, and it gives you a formula, so you need that for number 8. It's the formula I equals PRT. Okay, so interest is how much money extra, so it's the amount of money that you have to pay to borrow money. So like if I put my money in the bank in a savings account, the bank will hold it for me, and they're going to use the money, and they're going to pay me an interest back. They're going to pay me a percentage of the money that I put into that account. If I take out a loan, so like a car loan, a home loan, I have to pay not only what I borrowed, but an extra amount, an interest amount, which actually ends up being a lot for some of these items. So you're not just paying the number for the amount for the item, you're paying extra so that you could pay and buy that item off. So be wise with that. Some things are good to use interest on, and some things are not so wise. And I wish I had more time to talk about that, but we're going to work through these problems. Maybe when we see each other again, or you can watch my other videos on interest, we can talk about that more. Okay, but interest equals the principal. That's your beginning amount, the amount you put in or the amount you got, and then the rate. So how much percentage did you pay? What percent are you paying? So in this problem, number 7, it's a 2.8% interest. And then T stands for time, like how long in years did you hold that money, or did it take you to pay back that money, or how long did you let the bank hold the money, for example. Okay, so here I'm trying to find the interest, so I have $1,500, and then the rate is at 2.8%, and then the time in this problem was 4 years. And this is simple interest. When you get compound interest, which is really cool, you start using some exponents, and it starts making that money grow quicker. So, okay, if you borrowed 15, and I think this is more like a savings account. So if I put in $1,500 and I get 2.8% back, a very good savings account, maybe like a treasury loan, for 4 years, how much money did I make on that money? So I'm gonna get $1,500 back, but how much extra did I make? Don't forget, make your percentages into decimals. So really it's going to be 1,500 times 0.28. 1,500 times 0.028. I got to say that correctly. So 0.028 times 4. So $168. Okay? So that's how much interest this person received. Now you're like, what does that mean? In 4 years, at this percent interest, you made an extra $168. So you not only get the $1,500 back if you wanted to take all your money out, but you also get $168 for letting someone borrow that. Okay? With number 9, let's see our time. Yeah, we're good. Number 9. Lionel was charged 6.1% simple interest on a loan of $6,000. So this time, I'm taking out a loan. So $6,000 is the beginning amount, and then it was 6.1%. So I'm going to put 6.1%. Notice I left a little gap for my work. And 3 years. Okay, so this problem is a 2-step problem. It says he was charged 6.1% simple interest on a loan of $6,000. He paid the money plus interest after 3 years. Okay, how much did he pay altogether? Okay, so it's not asking me just for interest, it's asking for altogether. Okay, let's figure this out right here. Let's figure out the interest. So I'm going to move this decimal 1, 2. So I put in my calculator right the first time. 6,000 times 0.061 times 3. Okay, so I have 1,098. 1,098. So that's how much interest he paid. But it's saying how much did he pay altogether for that loan? So remember, he borrowed $6,000. He has to pay that back. But how much extra does he have to pay? The 1098. So you do the 1098 plus the 6,000 and you get the 7. So you added these two together, we get the 798 or 7098. So for a $6,000 item, he paid $7,098 because he had to borrow the money for that, whatever that item was, whatever that loan was. So interest is the amount of money somebody pays to borrow money. So whether you borrow money personally or you let the bank borrow your money, there's going to be interest exchange in that a lot of times. Okay, on number 11. Number 11 is kind of it's another compound problem, so you got to think of it carefully. Tony buys a $980 printer on sale for 25% off. 25% off. So that's a discount of 25%. What is the total of the cost of the printer, including a sales tax of 5.8%? Of the discounted printer. 5.8% tax. Okay, so first of all, this is how much the item is listed for. The printer costs $980. $980. But it's 25% off. So he's going to pay less than the $980 because it's on a sale. But then he has to pay 5.8% tax. So this is a two-step problem here. I'm going to find out what is 25% of 980. So first I want to find out how much is the discount worth. So I'm going to move that decimal, which is right here on a whole number, twice to the left. 0.25 times 980. So $245 that he saved. Okay. So how much money is he going to pay for that printer? You have to take the 980 minus the 245. And you get, okay, he pays $735. Okay, $735. That's how much he's going to pay for that printer. But he has to pay what? Tax. So now I want to find what is 5.8% of 735. And remember the decimal point, 1, 2. And so we've done this problem on a previous example. So 0.058 times 735, 42.63. Okay, so that's how much the tax is going to be on that discounted item. So it wants you to tell them how much is he paying for that item. So you take the 735 and you add the 42.63, and he's going to pay $777.63. So in this problem, you had to find a percent that gave you a discount. So I took that discount amount, so I did 25% of 980, okay? And I had to subtract that from the amount because it's a discount. It makes your price go down. That gave me $735. But taxes always make your price go up. So then I found 5.8% of $735, $42.63, and I had to add these two together to get my final price. So you can see the double problem in that. All right, the last problems, I'm only going to do one of the odd because they're pretty much the same. It's called a percent of change. And the percent of change, and I'll write here, percent of change has a little formula. And it's up there on the top of the page for the rest of the problems is amount of change over original amount. Amount of change over original amount. And and then times 100, because that times 100. So you're noticing 100s in every problem. You're moving the decimal twice, that's dividing by 100. Moving the decimal twice to the right is multiplying by 100. So on number 13, Kirk's starting wage was $12 per hour. That's the original amount. So here I have my formula. His original amount was $12 an hour. 1 year later he earns $13.50. So the amount of change is found by taking the new amount and the original amount and subtracting those, right? It's a 150 difference. If he was paid $12 and then now he's paid $13.50, it's a 150 change. And then I have to multiply that by 100, and then I'll give you my answer. So here we're going to do 1.5. Aren't you happy you don't have to divide? 1.5 divided by 12 gets me 0. Just make it accurate. 0.125, and then I had to multiply that by 100, which basically moves the decimal 1, 2. So his percent of change is 12.5%. That's how much his wage went up. So if he was getting paid 12 this year, next year goes $13.50. That's a 12.5% raise. So you can find that by the amount of change formula. Don't forget, percent of change is the amount of change over the original amount times 100. Original amount's almost always given to you. The amount of change is what you have to find out, then work it into that problem. Yep, and you're going to do numbers 2 through 18 even. 2 through 18 even. And that's going to be found on page 283, 284. And I'll have a Zoom session if you have any questions. It's optional, so make sure that you check that out if you're having issues. Okay, so there's your homework. I hope you have good time using your calculator to figure out these percent problems. Just don't forget, change percents to decimals, because then you can work them out on your calculator. All right, take care, guys.